Number 35. So, in this case, they're going to do this experiment, but they think that there's an additional variable here, and that is how heavy the people are. So what they're going to do is they're going to try to mitigate the effect of weight, and what they're going to do is they're going to put them into two separate groups, heavy and light. And they're going to do the experiment the same exact way. They're going to randomly assign people in the heavy group, the medication and not the medication, compare the results. Same thing with the light people, and then they'll compare the heavy and the light together in the end. This is an example of blocking. See, this looks like a block. Maybe that'll help you remember that that's blocking. So, blocking. They don't say that in the problem, but that's what they're doing, and the answer is A, which describes blocking. Okay, 35 is A. Now this is kind of a tricky one because they don't talk about sample size at all. All they say is in a recent story on Evening News cited a poll that said 4% of teachers in New Hampshire. It doesn't say, that's like everybody. It doesn't say a sample of teachers. 36% of teachers in California felt the same way. So, here's the problem. California is huge compared to New Hampshire. So, it really isn't correct to just add them up and divide by 2. Letter D is our correct answer. Right there. Okay, let's go to the next one. Seems like they like a question like this, so be careful. Number 37. We are calculating our slope by using all of these dots here. And we have this one low dot. So think of it as a weight that is pulling the slope down, because we're using every one of these point, the x and y, to figure out the slope. It's like the average of all these to figure out our slope. And then if we get rid of it, if we get rid of this weight that's dragging us down, the slope would increase. It's like a weight pulling it down. Same thing if there was a point above it. That's kind of like a balloon, like pulling it up, kind of thing. So anyway, in this case, we have this dot that's pulling the slope down a little bit. If we get rid of it, the slope will increase. Oh, but what about the correlation? So if we have this outlier out there, the correlation is going to be less. See, the more they're lined up like a straight line, the better the correlation. So the slope is going to increase, and the correlation is also going to increase. Which letter is that? The answer is B. Okay, let's look at the next one. Okay, on this one. This might seem kind of confusing. This teacher always assigns either 3, 4, or 5 problems. He assigns 3 problems 20% of the time. Half the time you get 4 problems, and 30% of the time you get 5 problems. But on average, how many problems do you get a day? Well, to do this by hand, you would do 3 times 0.2 plus 4 times 0.5 plus 5 times 0.3, and you would end up with 4.1 as your answer. Now I'm going to show you a trick. If you go to L1 and you just put in 3, 4, and 5 into L1, and L2, you're going to put the probabilities, right, like that. Now what you're going to do is you're going to go to one variable stats. Just be careful, because you want to change the frequency, which is, I think, blank, to L2. So that the frequency goes in there. And then it'll spit out, it'll say that the average is 4.1. And then it's going to say the standard deviation is 0.7. But we want the variance. Notice that they actually have that as one of our answers, D, which is not correct. That's the standard deviation. So the standard deviation is the square root of the variance. So if we have the square root, how do we get the variance? We square it. And if we square that, we get 0.47. 9. Remember, the standard deviation is the square root of the variance. Okay, so we end up with letter C is our answer. Okay, this one's kind of tricky. I had to read it a couple of times. Now, it really comes down to this p-value of 0.1379. Okay, so at the 10% level, right, we would actually fail to reject. Okay, that's what that's saying. D says the mean number of items is not significantly different, meaning we don't have enough evidence. Okay. It's worded a little bit weird, so D is the answer. E doesn't work because it says it's not significantly different, but at the 15% level, we would actually reject the null hypothesis and say it is significantly different. But anyway, letter D is the answer. Just have to read it extremely carefully. It all has to do with these alpha levels. Where do we reject and where do we fail to reject? Okay, here we go, number 40. So I'm going to do a Venn diagram on this one. Here we go again. These circles, right? We got this guy, we got this guy. Let's see. What do we got? Calculus over here and statistics over here. So I start with the one that they're enrolled in both. So 5% enroll in both. So 0.05 are here. So of the people that 60% are in statistics, so 0.55, because that includes the people that are in both. And then 12% are in AP Calculus, so that's going to be 0.07 over here. And then the rest are in neither class. Okay, let's see, what do they want to know? Oh, so it looks like they want to know how many are not in either class. So add all this stuff together and subtract from 100. So, not really 100. All these numbers have to add up to 1, but same thing. 33% or 0.33 is here. And the answer is C. Okay, that's the end of practice exam 2. Okay, done.